looked at force P and Q, that how the P and Q forces are caused. Second thing, whether vessel will have plus P or plus Q or plus minus P or minus Q, it will depend on what, how force P and Q are changing the deviation on different headings. That is what we have seen. And then we had started with force R. And then statement was made yesterday by me that force R is, first of all, what is the force R? Force R is the vertical component of the ship's forward magnetic field acting at the compass position. So let us just a little bit recapitulate. Let us say this is the ship, this is the forward, this is the aft, and the total force acting at the compass position is this. The fore and aft component is called P, a third shape component is called Q, and vertical component could be R. And R we had called it is positive if it is acting vertically downward, and R by sign convention it is negative if it is acting vertically upward. In this case we can say R is positive. So whether F shape will have plus R or minus R, it will depend on what? It will depend only and only on the hemisphere in which the vessel was built. So that is the point where we finished the last lecture. How it will depend on the hemisphere in which the ship was built. Let us say this is the Earth. Okay, let me take out the other pen. Okay, so let us say this is the Earth. Let us say your ship is being built in the northern hemisphere. Let us say the ship is being built. Okay, so this is the forward and this is the aft of the ship, and the ship is heading in this direction. So now how the Earth's magnetic lines of forces are going. So here you have the North Pole. Actually, it is called South Pole, but actually it is the North Pole. This is South. So because of that, the lines of forces which are going will be going like this. So the lines of forces which are going from here, okay, will be passing through the ship like this. So the lines of forces which are passing through the ship will be like this. So when the lines of forces which are passing from the ship is, this is the forward and this is the aft, let us say. So lines of forces, and they are passing like this. Okay. That means from top to bottom. So then what will happen? Finally, what you will have? That you will have these blue poles here that we have seen earlier. Blue, 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 and blue. Okay. And this will be red, 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 red. So the keel of the ship will become red and the deck of the ship will become blue. So finally, the force will be acting from this red to this blue. That means the force will be acting basically in what direction? Force will be acting in this direction. In this case. So after this red and blue poles have been caused, okay, red pole here. Okay, let me show it by colors only. So red poles are caused here, and blue poles have been caused on. So because the lines of forces, okay, were coming like this. So as you can see, the ship is being built like this. So the lines of forces will be coming like this, or will be coming like this. That means they will be entering the ship from the top, from the deck side, and exiting from the keel side. So obviously, the top part of the ship will become blue, and the bottom part of the ship will become red. So after these red and blue poles have been formed, they will become permanent. So the lines of forces will be now be passing from red to blue within the ship. So that force will be somewhere in this direction. Okay. In this case, what will happen? When you take the component of this, so fore and aft component is going towards aft, a thrust component is going towards port, and vertical component is going towards aft. So even if the total force acting in this direction, so vertical component will come out to be vertically upward only. So what we take from here, that a vessel which is built in the northern hemisphere will have minus always minus R. Is it clear? Because the net force acting on the compass position will be either in this direction or in this direction. So when you take a vertical component of that, the vertical component will come out to be in this direction. So vertical, if R is negative, it is acting vertically downward. So in a northern sphere, you have minus R. And similarly, we can say in the southern hemisphere, we will have plus R. Like a similar illustration. Is it understood? Hello?
Sir, can you repeat, please?
So I am saying that a ship which is built in the northern hemisphere will always have minus R. And the ship which is built in the southern hemisphere will always have plus R.
So can you please explain how, sir? Where I did not get it.
Okay. Let us say this is the surface of the Earth, and your ship is being built in the northern hemisphere. So let us say this is your ship. Okay. This is the ship which is being built in a northern hemisphere. So lines of forces which are coming out, because you have the North Pole here and South Pole of the Earth. So the lines of forces are going like this. So the lines of forces which are coming out like this, okay, they will be entering the ship like this. Okay. Is this part understood?
Yes, sir.
That means they are entering from top of the ship. That means they are entering from the deck of the ship and exiting from the keel of the ship. Okay. So if the same thing we can show in a diagram here, same thing we are showing. Okay. So let us say this is the forward and this is the aft of the ship. Here actually heading does not matter. So it is entering from aft. So it is the lines of forces, arithmetic lines of forces are going like this. Same thing what is shown like here. Is it clear? Whatever is here, same thing I have shown it here.
Yes, sir.
So this is the forward of the ship and this is the aft of the ship. So because the arithmetic lines of forces are entering from this side, so this becomes blue, blue, and blue. And due to induction, that this will become red, red, and red, and red. So once this induction is done at the time of new building, then these blue poles and red poles become permanent poles, and they will remain so throughout the life of the ship. So let us say you have a compass here. At this compass position, the force will be acting from where? This red to this blue. Now the induction is complete. Forget about these forces. These forces have done their job in creating the blue pole and red pole. So now these are this we are not this we already considered. So now I'll concentrate only on this blue pole and red poles. That means this ship has got red pole somewhere in the bottom and blue pole somewhere on the deck, on the top of the ship. So the lines of forces within the ship will be always going from red to blue. That means they will be always going vertically upward.
Yes, sir.
So the lines of forces are going in this direction, let us say, at the compass position. It could be this direction or it could be this direction. Right? Right? Hello?
Yes, sir.
So whether when you take a vertical component of this, the vertical component will come out to be like this, or the vertical component will come out to be vertically downward. Say आपका ship है, this is the ship. Let us say this is the ship. Duster is the ship, and let us say that that force which is acting in this direction. This is the bottom of the ship, and this is the top of the ship, and this total force is acting in this direction. तो इसका जब vertical component लोगे, तो vertical component तो यही आएगा ना, showed by this black man.
Yes, sir.
It will not come like this, na? So because in the northern hemisphere, the arithmetic lines of forces will always be entering from top and exiting from bottom. So that means the deck will always be blue and the bottom will always be red. So that means the lines of forces will always be in the vertically upward direction, in a oblique direction. So when you take a vertical component of that, that will come out to be vertically upward, correct?
Yes, sir.
So that is why in the northern hemisphere, you will always have R acting vertically downward. That means in the northern hemisphere, you will have minus R. Vertically downward means plus R, and vertically upward means minus R. And that means in the northern hemisphere, you will always have minus R. Similarly, you can see in the southern hemisphere, if you take the southern hemisphere like this, so the lines of forces are going like this. Earth's lines of forces are going like this, in this direction. So then what you will have? You will have all blue pole here, and you will have red pole on deck. So the lines, so the deck is becoming red, and now keel is becoming blue. So the lines of forces will be in the vertically downward direction. So when you take a vertical component, that will come out to be vertically downward. Right?
Yes, sir.
Hello.
Yes, sir.
So northern hemisphere always minus R, southern hemisphere plus R. And here the heading doesn't play any role because vertical is vertical on any heading. Whether your ship is going heading in this direction or this direction or this direction doesn't matter. If the lines of forces are going like this, whether you are heading in this direction or this direction, it doesn't matter. So heading doesn't play any role as far as the force R is concerned. Okay. So what conclusion we have got? That a ship which is built in the northern hemisphere will always have minus R. A vessel which is built in the southern hemisphere will always have plus R. A vessel which is built at equator, what will happen? Or you can understand this in this way also, that when we talked about the Earth's magnetic field, this Earth's magnetic field we had divided into two components. This is the Earth's magnetic field. The horizontal component we call it H, and vertical component we have called it Z. This horizontal component of the Earth's magnetic field was inducing the magnetism in the horizontal plane of the vessel, and this one was causing this force P and Q. And this vertical component of the Earth's magnetic field will cause the magnetism in the vertical plane of the vessel. So it is basically the vertical component of the Earth's magnetic field, which is Z, which is responsible for this force R. So what is the inducing field for R? It is Z. Okay, so if you look at, because in the northern hemisphere, okay, what is the direction of Z? Z is acting vertically downward. So obviously this will become blue and this will become red. So the lines of forces will always be going from red to blue. Okay. So the vertical component of the Earth's magnetic field, which is Z, vertical component of the Earth's magnetic field, which is Z, will induce the magnetism in the vertical plane of the vessel, causing R. So what is the inducing force for force R? What is the inducing force for creating force R is basically Z. Okay. So northern hemisphere minus R, southern hemisphere plus R. A vessel which is built at equator, okay, that ship will have what? Will have R or will not have R? A ship which was built exactly at equator,
Not R.
no R. Why? Because here the value of Z is 0. H is maximum at equator and Z is 0. So when the inducing force is 0, the induction in the vertical plane of the vessel will also be 0. So no R. When we say poles, okay, if the vessel is, let us say, built at poles, hypothetically, so there the value of Z will be maximum. So the inducing force is maximum. So the induction will also be maximum. So maximum R will happen at. So now we talk about, after having understood that what all factors will affect the what all factors will determine minus R and plus R. So it is only the hemisphere. Now let us talk about the magnitude of R. How much R the vessel will have will depend on what? Number one. Will it depend on the heading? Heading doesn't play any role. The heading is out. Second thing, change of place, or we can say latitude. With the change in latitude, will there be in change in value of R? When we say latitude, it is the latitude in which the ship was built. It is the latitude in which the ship was lying for a long period of time and the vessel was being built. Okay, so latitude means when you Z is 0 at equator and Z is equal to maximum at poles. And when we are traveling from equator towards the pole, the value of Z is what is it is increasing. So that means the higher the latitude in which the vessel is built, the more force R the vessel will have. Okay. So a vessel which is built in the latitude of 50° north is likely to have more force R compared to a vessel which is built in 20° north latitude. Okay. Because in higher latitude, the inducing force is strong, so the induction will also be likely to be strong. Number two, it will depend on duration that we have already discussed. So all other three are mechanical factors, which will not go into detail as we have already discussed. So it will depend on duration of the build, how long the vessel was lying in the when the ship was being newly built. Okay. Number three, it will depend on what next thing is it was built. It will depend on the what we say the amount of hard iron. How much is the hard iron present in the steel of the ship? And number four, that moderate hammering and heating. So this point number 2 and 3 and 4 are common to what we have discussed to related to force P and Q. So that we are not going to discuss. So these are the four things which are going to affect the magnitude of R. To sum it up, force R plus or minus depends on hemisphere. Northern hemisphere minus R, southern hemisphere plus R. Magnitude of R will depend on what latitude in which the ship was built. Higher the latitude in which the ship is built, more R the vessel is likely to have. Second is duration of the build, amount of hard iron, and moderate hammering and heating. Okay. Any doubt? After having seen this force R, now let us see that what effect it will cause at the compass position. Let us say I am drawing one ship. Okay. So now we are looking at the ship from aft. So somewhere here is a propeller. So this is become the starboard and this becomes. And let us say the ship is sailing in a northerly direction. So what is this? This direction is north. This direction है. This is the direction of north. So ship is going in this direction. You can say ship is going in this direction. And this direction is north. Okay. Now let us say this is a magnetic compass. And let us say the force R is acting vertically downward. So this is the force R. And at this moment the vessel is upright. No list. Will this force R cause any deviation? Will this force R cause any deviation?
No, sir.
Why this force R will not cause any deviation? Because it is a vertical force. So what will be the horizontal component of this? So this component, horizontal component will be 0. So that means due to force R, in this case there is no horizontal force. And what is this? What is deviation? Deviation is something which is happening in the horizontal plane. All this force P, force Q, force H, everything is in the horizontal plane. So then when due to force R, the deviation, the force in the horizontal plane is 0, that means it will not cause any deviation. So force R does not cause any deviation. It doesn't take part in the deviation. Is it clear? जैसे आपका शिप ऐसे है, शिप ऐसे जा रहा है और ये फोर्स आर इज एक्टिंग वर्टिकली डाउनवर्ड, ऐसे लग रहा है, फोर्स आर इज एक्टिंग लाइक दिस. तो ये शिप को ऐसे थोड़ी घुमा पाएगा, सॉरी मैग्नेटिक कंपास को ऐसे इस डायरेक्शन में, इस प्लेन में थोड़ी घुमा पाएगा. So it is acting perpendicular to this. It will not turn the magnetic compass in the horizontal plane. Okay. Is it understood?
Yes, sir.
Now let us say that vessel is rolling, or vessel is listed to port. So we are drawing a diagram with the vessel heeled over to the port side during the rolling. This is starboard, this is port. The magnetic compass will try to remain horizontal because of the gimbals. Okay. Now the force R is acting in this direction, or the force R will be acting in this direction. Which option is correct? 1 is correct or 2 is correct?
So 1.
1.
Correct? So option 1 is correct. Because remember, this force R was what? Vertical component. Vertical component with respect to what? Ship, not with respect to Earth. When we have resolved this force, okay, in P, Q, and R, this is with respect to ship's fore and aft line, ship's athwart ship line, and the ship's vertical line. So what is the ship's vertical? Ship's vertical is this. This is the ship's vertical. That means perpendicular to the keel and deck. So now the force R is something which is acting perpendicular to keel and deck. And you can say parallel to fore and aft bulkhead. So that is what is there. It is perpendicular to keel and deck. So this angle is 90. Now this, in this position, this force R is no longer, you can say, vertical with respect to Earth. That means it will have a vertical component like this, and it will have a horizontal component like this. This vertical and horizontal component is with respect to Earth. Understood?
Yes, sir.
So will this horizontal component deflect the magnetic compass?
Yes, sir.
So because the ship is moving in this direction, and this component is acting in this direction. So what will be this direction? Easterly. So your magnetic compass in this case will be deflected towards the east.
Yes, sir.
Because of this force, the magnetic compass will get deflected towards the east. Okay. So what this deflection is called? This deflection is called as heeling error. Because it is happening during the heeling, when the ship is rolling. And in this case, what we will have is heeling error. In this case, the heeling error will be easterly. Any doubt? So when the vessel heels over, let us say in this case towards the port side, the force R is always acting perpendicular to keel and deck. So here it was vertical with respect to the keel and deck, and it was also vertical with respect to Earth. But now it is vertical with respect to the ship. It is no longer vertical with respect to Earth. So it will have a vertical component and a horizontal component. Again, this vertical component will not do anything, but this horizontal component, so it is acting in the easterly direction as the vessel is moving in the northerly direction. So it will cause a easterly deflection of the magnetic compass. So it will cause a healing error, which in this case we can say it is easterly. If the vessel now rolling, vessel was rolling like this, now port, now it goes to starboard. Vessel is going to the starboard. So now what will happen? Let us see. Again, your magnetic compass will always try to remain horizontal because of the gimbals. And force R is acting vertically downward like this. So if I take a vertical component and if I take a horizontal component like this. So now you can see this horizontal component is acting towards west. So the ship is going in the northern direction. This is port and sorry, this is starboard and this is port. So when the vessel is heeled over to the starboard side, okay, your horizontal component of this R is acting in the vessel direction. So again, you will have the healing error. But in this case, the healing error is right. So during the port heel, you are having a healing error westerly, and during the starboard heel, you are having a healing error westerly. तो ये ऐसा नहीं कि this easterly and westerly we are writing with respect to vessel heading north. ऐसा नहीं कि port hill पे आप easterly जाएगा, starboard hill में westerly जाएगा. So what is happening as the vessel is rolling? Let us say vessel is going in this direction. So when the vessel is heeling, so easterly healer, westerly healer, easterly, westerly, easterly. That is why you may have observed that when the vessel is rolling, at the time your magnetic compass is not steady, it is oscillating. Have you observed?
Yes, sir.
Okay, so when the vessel is rolling, you may have observed that the magnetic compass is oscillating. It is not steady. So that is due to healing error. Okay.
Okay, sir.
Okay, and it is due to healing error, and also and the healing error on your ship is not corrected properly. If the healing error is corrected properly, then during rolling also the magnetic compass should not oscillate. But because the healing error is not corrected properly, that is why that magnetic compass oscillation can be seen at the time of rolling. तो इसको करेक्ट कैसे करते हैं? करेक्ट कैसे करते हैं? इसको करेक्ट करते हैं समथिंग विद अ परमानेंट मैग्नेट. लेट अस से हमारे शिप पे पता चला कि हमारा फोर्स आर जो है वो वहां काम फोर्स आर वाज एक्टिंग वर्टिकली डाउनवर्ड. So this is only one type of healing error I have shown. Similarly, there is other types of healing error also, that is induced healing error, but that we are not going to discuss. That was there in the course long time back, but now it is no longer. So let us say that this total force is acting at the vertical at the compass position in this direction. So if I want to correct this force, what I should do? I should create an equal and opposite force at the compass position, so that I should create a force in this direction. So this is the force R which is causing the healing error. So I should create an equal and opposite force at the compass position. Right? So how do we create? What we do is that we keep a vertical magnets below the compass. We will keep the vertical magnets below the compass. Some of you, if you have opened the binacle, you would have seen a healing error bucket. In that healing error bucket, okay, you have this vertical permanent magnets. And in this case, we will keep the red end of this magnet on top, north end on the top. So when the north end on the top or red end on top, obviously the blue end is down below. So that we need not show. Now, and the magnetic compass you always treat it as a red. That means the magnetic compass we always take as a red. So this red will deflect the magnetic compass red So then it will create a force in this direction. This will create a force in this direction. This blue is also creating a force at this point, but this blue is far away from red. And as you know, the magnetic field is very much dependent on distance. So approximately for short bar magnet, we can say the magnetic field B is inversely proportional to the q of the distance. So let us say if this end is, let us say, 5 times closer than this end compared to the compass, then the effect of this will be 125 times stronger than the other end. Q 5 का cube कितना हो गया? 125. Understood? Hello.
Yes, sir. Yes, sir.
Yes, sir.
And if the force was acting in the vertically upward direction, causing the healing error, then we would have done? We would have kept the blue end on top. How will you find out that whether force R is acting vertically upward or vertically downward? That you can find from here also. अगर यहाँ पे अभी आप देखो, आपको इस पोर्ट हिल पे क्या मिला? ईस्टर्ली. And starboard hill पे क्या मिला? Westerly. Let us say if force R was acting vertically upward, then the vertical component is going like this, and the horizontal component is like this. So then here you will have westerly, right?
Yes, sir.
And let us say again, you see here, if the force R was acting in this direction, then instead of vertically downward, it was acting in vertically upward direction. So the vertical component will go vertically upward, horizontal component will go towards east. So here you will have easterly. So if on the port heel you are getting easterly error, that means it is R is acting vertically downward. If on the port heel you are getting a westerly healing error, that means it is acting toward the force R is acting vertically upward. Correct? Okay. But actually healing error on the ship is corrected by something which is known as vertical force instrument. It's called VFI, vertical force instrument. So vertical force instrument is vertical force instrument, which is not there in your syllabus. So we are not going to discuss that. Earlier, the magnetism portion was very large. Okay. When we appeared for our masters, that time the NAVEDS paper was separate and the compass paper was separate. In that compass paper, we used to have 6 magnetism questions and 2 gyro questions. Separate 3 hours paper. That time the portion of magnetism was enormous. Then it was reduced little bit. Let's say 20% was reduced. And that 20% reduction was there until about 6, 7, 8 years back, or 9 years back, or 10 years, until about 7, 8 years back, 9 years back. That time also 3 or 4 questions in the NAVEDS paper used to come from magnetism. Then the portion was reduced, and that time I used to take about 65 lectures in the entire phase 2. And there used to be numericals, and there used to be all the instruments, and about 60-65 lectures to complete the entire magnetism syllabus. Now the portion has been reduced to a large extent, and the numerical part has been totally reduced. All the equipments have been reduced. Okay. So if this is understood.
Yes, sir.
So healing error is actually an error which is not corrected for all the places. That means the healing error should be adjusted when the vessel is going from one place to the other place. All other deviations or all other errors or all other deviations, like caused by force P, Q, and all that. That is, once they are corrected properly, that correction is good for all the places. But healing error is the only one which is corrected, and it is the correction is valid only for the place where it is corrected. When the vessel goes from place A to place B, and let us say place A, the healing error was corrected by keeping that vertical magnets. At place B, the healing error will appear again. Okay. So again, that healing error bucket has to be at position, has to be adjusted. Okay. So you have a binnacle like this. You have a binnacle, let us say carbon. In the center, you have a healing error bucket. There is a healing error bucket here like this. Yeah. And in this, the vertical magnets are there. And the position of this magnet, you can bring it closer to the compass. Sorry, position of this bucket, you can bring it closer to the compass. Let us say compass is here. Or you can take it away. If you want more healing error to be corrected, you can bring them closer. If you want less healing error, then you can take it away from the compass. And how you take it away and this thing? So there is a arrangement provided wherein there is a chain which is going like this, and it is going to the other end. And there are weights here. If you increase these weights, what will happen? So let us say it is attached here. So if you increase this weight, what will happen? This will go upward. And if you reduce this weight, then it will come down. So that is how the healing error can be, the healing error correction can be increased and decreased on board the ship by the ship staff. Okay. Hello. So practically, what you can do, that let us say the ship is rolling and somebody is there on the monkey island. Not that it is rolling very heavily and you are going on the monkey island. Let us say the ship is rolling and your magnetic couple is oscillating. So you adjust this height so that the oscillation becomes minimum, and then you lock it in that position. Understood? So no need of any calculation or anything. You can just do it by observation. So that in what position your magnetic compass becomes steady during rolling. So that is the position of the bucket you should have at that time.
So, but the healing error will also depend on the angle of heel, no, sir? At that time. So, like if the vessel is healing about 5 degrees and suddenly it's just healing more.
Scale of course, it will depend on angle of heel. It will also depend on the course also. Okay, so all those things are not there in your syllabus because earlier that healing error the healing error topic itself used to be 5-6 lectures. Okay, so but you see, once you have nullified that force R, once your force or once the vertical force acting at the compass position has become 0, let us say you have made the force R 0. After that, does it matter
No,
how much heel you are having?
No, sir.
Huh?
No, sir, it does not matter.
So that is what is it. Once the vertical force has been made 0, after that it doesn't matter how much heel you are having. Okay, so when your vessel is rolling like this, you try to adjust this bucket so that your magnetic compass becomes steady. So that means you have reduced the force R. Force R and also other forces acting causing healing error. So here we are discussing only one of the force R. Okay.
Yes, sir.
Okay. So that is about the hard iron magnet. Now we go to the next part, that is soft iron magnetism. So soft iron magnetism is, of course, a little bit more complicated compared to hard iron magnetism. Because in hard iron magnetism, we had these 3 forces. Okay, force P, force Q, and force R. And all these 3 forces were permanent forces. And they remain permanent throughout the life of the ship. Okay. but the amount of deviation what this force P and Q was causing, that was different on different headings because of the angle what this force P and Q is making with the H. Because of that, you have different deviation on different headings. Okay. So that means the heading was playing a role here in terms of amount of deviation because of the angle between P and H and because of the angle between Q and H. What happens in the soft iron magnetism is the induction itself is dependent on heading. Here, let us say the induction is permanent, but now what happens in the case of soft iron? Soft iron is an iron which will receive the magnetism, or magnetism will get induced fast, very fast. But as soon as the cause or the inducing field is removed, it will also lose magnetism very fast. So easy to magnetize and easy to lose the magnetism. So on the ship, we are having 3 types of soft iron. Okay, all the structures of the ship, either they are fore and aft. Well, structures mean this structures the ship bana hua hai. Okay, so all the structures, leaving that few structures like in the bridge wing, you are having pillars that may be in the some oblique direction. Otherwise, mostly all the structures are either fore and aft, like your girders, fore and aft girders, or you are having a throat shape, that is your bulkheads and beams, or structures are vertical, like your mast and funnel. The ship is made of 3 types of soft irons. One is a throat shape horizontal soft iron, fore and aft horizontal soft iron, and vertical soft iron. So a throat shape horizontal soft iron we show like this. This you can say bulkheads and beams. Fore and aft horizontal soft iron we show like this. This is representation. Okay. Fore and aft horizontal soft iron you can say fore and aft girders. And vertical soft iron we show. How do we show vertical soft iron? Vertical soft iron, let us say this is the compass position. So we show the vertical soft iron like this. Like this, like this. Let us talk about this and this. Now, if you look at the approach shape horizontal soft iron, what is this? This is approach shape horizontal soft iron. Because it is a throat shape, it is horizontal, it is soft iron. Okay. So it is not having any magnetism of its own. So it is because it is a horizontal soft iron, which is the inducing force, which is the force of the earth, which will cause the induction in the horizontal soft iron. It is H. What is the inducing force here? Is horizontal component of the earth's magnetic. And what is the direction of H? H is always acting towards north. Now, as you know, let us say in this case we are ignoring the width of this. Now, what happens that if you look at the induction, okay, let us say I keep a magnet like this. So this will become blue and this will become red. So it will receive maximum induction in this case. This iron piece, because of this inducing field, will receive maximum induction. If I keep this iron piece like this, will it receive any induction along the length? Huh? No. It will, here you will have maximum induction and here you will have zero induction. Because the lines of forces are entering like this. Na? So यहाँ से तो कुछ enter नहीं हो रहा है, यहाँ से भी कुछ enter नहीं हो रहा है. So here the induction along the length will be zero. Forget about this induction. Some people may say कि नहीं induction तो होगा, ऐसे होगा. ये वाला तुम्हारा यहाँ पे blue हो जाएगा, यहाँ पे red हो जाएगा. Because the lines of forces going. So you ignore the width of this. Will there be any induction along the length?
No, sir.
let us say if I keep it like this, will there be some induction? Yes, but it will be less than the maximum induction what is happening here. Of course, it will be more than 0. So the more the piece of iron is aligned with the direction of the field, more induction it will receive, like in this case. And if it is lying perpendicular to the direction of the inducing field, it will receive 0 induction. Is it correct? Understood?
Yes, sir.
So here the inducing field is H and horizontal software is like this. So will it receive any induction?
No, sir.
Well, actually, what is this position that your ship is, let us say, heading in this direction, and you are this in this direction. So it will not receive any induction. Okay. So here induction is 0. So when the induction is 0, so when this is not induced only, so then deviation is also 0. For the deviation will come into picture only there is induction. Let us say now this ship goes in the westerly direction. Now this is a third ship horizontal software, so it will become like this, port and starboard. So now it will receive maximum induction. So this end will become blue, and this end will become red. So because of this red and blue pole, this blue and red pole induction is caused by H. But once this blue and red poles have been caused within the ship, so within the ship the force will be going from this red to this blue. So now this force is acting towards aft. So will this cause any deviation? Will this force cause any deviation? Here also the deviation will be 0. Why the deviation is 0 here? Because this force is acting in the southerly direction and force H is acting in the northerly direction. So this force is acting opposite to H. That means there is no angle between H and this force. So that means there is no deflecting component of this force. That means the deviation is 0. And what will happen to the induction? Induction is maximum, but the deviation is 0. Here the induction is 0, the deviation is 0. Here the induction is maximum, deviation is 0. Okay. If there was induction here, let us say it was red. Let us say there was induction here, red and blue. If there was induction here, then the force would have been acting from this red to this blue, like this. So then it would have caused the maximum deviation because the force is acting perpendicular to H in this case. Right? If there was an induction of this horizontal soft iron, and let us say red pole was towards port side and blue pole towards the starboard side, then the force would have been going from this red to this blue within the ship. So this will be acting perpendicular to H. It would have been going in this direction. So it would have caused maximum amount of deviation, correct? Hello?
Sir.
But why the deviation is 0 here? Deviation is 0 because the induction is 0. If there was deviation, it would have caused maximum. If there was an induction, it would have caused maximum deviation. But here the deviation is 0 because induction is 0. Here the deviation is 0 even after having maximum induction, because the force which is generated is acting in the southerly direction. You can see deviation 0, deviation 0. But the cause here is that induction is 0. That is why the deviation is 0. Here the cause is even after having maximum induction, the direction of the force which is generated is acting opposite to H. So you can see that heading is playing two roles here. The ship's heading is playing two roles. One is that how much induction it is causing in this, and after the induction, which is when it is caused, then how much deviation it will produce. So there are two variable factors. In the case of P and Q, it was only one variable factor. That means what is the angle between H and force P and Q. Here, that factor is there. That what is the angle these forces are making with H. But there's one more factor, that because of the change in heading of the vessel, how much induction is being caused, because on different headings you will have different induction. Understood?
Yes, sir.
Okay, so let us say if the vessel goes in the northeasterly direction. Okay, so then you will have blue will become like here, red will become here. So the lines of forces will be going from red to blue. It will have a southerly component and easterly component. What will have? Easterly deviation. Okay, so it is not that it will not cause deviation, it will cause deviation. But deviation is 0 here, deviation is 0 here. But the reason for deviation 0 is different. Relation for deviation 0 is different here. So if you look at fore and aft horizontal soft iron, it will become blue here and red here because the H is going in this direction. So the force within the ship will be going in this direction. The deviation will be 0. Deviation is 0. Deviation, the induction is maximum on northerly heading for and aft horizontal soft iron. So, but the deviation is 0. When the vessel goes on the easterly deviation heading, okay, so now this one is like this. In this case, this fore and aft horizontal soft iron will receive any induction.
Sir.
No induction.
So induction will be 0. So the deviation will also be 0. So here there are two variable factors. How much induction will be caused on that heading, and after the induction which is caused, then the force which is generated, what is the direction of that force and what angle that force is making with H. So these two things combined together will give us the result that how much deviation will be caused on that heading. Is this understood? Okay. So study of this soft iron magnetism is done with the help of one concept which is called concept of soft iron rods. Soft iron rods. So in the short, we will be calling it SI rods, soft iron rods. This is the best way to represent the soft iron magnetism on the ship. Okay, so in the case of permanent magnetic field, force P, force Q, and force R, how much deviation they were causing on different headings was different. That means every force which is acting in a fore and aft direction and athwartship direction and vertical direction is causing different effect at the magnetic compass position. That means we have to resolve each and every force in 3 directions: fore and aft, athwartship, and vertical. So on the ship we have 3 types of soft iron. One I have told you already today. It's called athwartship horizontal soft iron. This athwartship horizontal soft iron can create a force in the fore and aft horizontal force. This can cause horizontal force, athwartship horizontal force at the compass position, and this can create a vertical force. So induction in this athwartship horizontal soft iron can create 3 types of forces, or the induction in this athwartship horizontal soft iron, the force which is acting at the compass position, that can be resolved into 3 components: fore and aft horizontal component, athwartship horizontal component, and vertical component. Same like previous one. Similarly, this 4.5 horizontal soft iron, okay, like this. This can also cause the force in the 4.5 horizontal plane, the hardship horizontal plane, and vertical plane. And similarly, this vertical soft iron, okay, this vertical soft iron can also cause the force in the 4.5 horizontal plane, the hardship horizontal plane, and vertical plane. So what will be this force? It is a hardship horizontal soft iron creating a 4.5 horizontal field. So instead of force, we can call it field. We can call it field. Vertical. So a hardship horizontal soft iron creating a 4.5 horizontal field. A hardship horizontal soft iron creating a hardship horizontal field. A hardship horizontal soft iron creating a vertical field. 4.5 horizontal soft iron creating a 4.5 horizontal field. A 4.5 horizontal soft iron creating a hardship horizontal field. And 4.5 horizontal soft iron creating a vertical field. Okay. Then vertical soft iron creating a 4.5 horizontal field. Vertical soft iron creating a hardship horizontal field. And vertical soft iron creating a vertical field. So basically, we have got 9 components. That is why, in order to show these 9 components, we have rods. And how many rods are there? Obviously, 9 soft iron. So study of soft iron magnetism is done with the help of these 9 soft iron rods. So what are these soft iron rods? These soft iron rods are basically, it is not something which is physical. It is a concept. Actually, it is a mathematical concept, but we will not be studying the mathematical part of it. We'll be only studying the physical part of it. So it is a way to show the effect of the soft iron magnetism. So it is a concept to describe, or it's a concept to explain the soft iron magnetism of the ship at the compass position. Okay, so these are not physical rods. This is just a way of showing the effect. So before we go for this 9 soft iron rods, and this is the last concept you are having in the magnetism. After we finish this soft iron rods, after that it will be just the application of what we have done until now. Then we'll start applying. There will be no new concept which will be coming. It will be only the application of what we have studied till now. Okay, everything will be use of this what we have studied till now. Understood? Chalo, we'll stop here today. Then we'll continue with the soft iron rods in the next lecture. Okay.
Thank you, sir. Thank you, sir.